Alright, so this is the last of 3 videos for test 3 review. So in number 16 we have f of x equals the quantity x minus 4 over the quantity 3x plus 2. And so we're supposed to find the domain here. So we know we need to look at the denominator and figure out what x value would make the denominator 0, which would make this fraction undefined. Well, the easiest thing to do here is just to set your denominator equal to 0. And so we'll get 3x equals negative 2. I just subtracted 2 on both sides. We'll divide by 3, we get x equals negative 2/3. And so the domain is basically everything except negative 2/3. If you find f of negative 2/3, your denominator would be 0, which makes you undefined. And so x cannot equal negative 2/3. That value cannot be part of the domain. The domain consists of all the numbers we can plug in as inputs, and our output is a real number. This is the only one where we won't get a real number output. Will be undefined. So our domain is negative infinity to negative 2/3, union negative 2/3 to positive infinity. Alright, let's look at number 17. Find any vertical, horizontal, and or oblique asymptotes. So first of all, let's look for vertical asymptotes. We know those occur when our denominator is 0. So any x value that causes our denominator to be 0. So we want to factor the denominator here. I need two numbers that multiply to negative 24 that add to negative 2. It's going to be 4 and 6. And I need the 6 to be negative. Notice 4 times negative 6 is negative 24. And 4 plus negative 6 does give you the negative 2. So you can see that x could never be negative 4 or 6. And so that's where we're going to have our vertical asymptotes. We learned that wherever you have a restricted value, that's where you will have a vertical asymptote on the graph. Now for horizontal asymptotes, there's 3 cases. This is the case where the degree of the numerator is less than the degree of the denominator. The way I like to say that is this is bottom heavy, which means the asymptote is at y equals 0. So anytime the degree on the bottom is greater, you're bottom heavy, the horizontal asymptote is at y equals 0. We won't have an oblique asymptote since we had a horizontal asymptote. Let's move on to part B. So for vertical asymptotes, that's going to occur where any restricted values are. Well, notice x cannot be 1 here. That would cause our denominator to be 0. And so x equals 1 is a vertical asymptote. Now, because the degree of our numerator is greater than the degree of the denominator, in other words, we're top heavy here, we don't have a horizontal asymptote. I'll just write none. But what we do have is a oblique asymptote. So we'll call that an OA. So to find it, we actually need to divide 2x squared plus x minus 1 by x minus 1. And because it's a linear factor with a 1x here, we can do synthetic division. So we'll put 1 in the box. Our coefficients are 2, 1, and negative 1. So drop the 2, you get a 2. 2 times 1 is 2. When you add, you get 3. 3 times 1 is 3. And here when you add, you get 2. And so let me write this in a different spot. We said x can't be 1. But when we do the division, our answer is going to be, let's see, this is squared, so we're going to drop our degree 1. It will be 2x plus 3 plus our remainder, which is 2, over our divisor. So we learned that this value here, these two terms here, are going to make up our oblique asymptote. Excuse me. So we get y equals 2x plus 3. The basic idea is as x gets really big, and that's what horizontal asymptotes and oblique asymptotes are basically used for. They help us to know what's going on the ends, and our graph is going to approach the horizontal asymptote or oblique asymptote on the ends. So as x gets really big, this fraction will get closer and closer to 0, and our graph or our function is going to approach y equals 2x plus 3. So that's going to do it for that one there. Let's move on to number 18. Now we're going to do a graph. So first of all, we need to find any asymptotes. So vertical asymptotes, we'll have a vertical asymptote at, let's see, x can't be -4 here. That would be our restricted value. So that's where our vertical asymptote is. -4, x equals -4. So that's our vertical asymptote. Let's go ahead and put that on the graph here. I'm going to go ahead and move this up. Horizontal asymptotes. The degree of the numerator is 0, the degree of the denominator is 1, so notice we're bottom heavy here, so that would be y equals 0. That's going to be our horizontal asymptote. Let's find some intercepts. To find the y-intercept, we'll find f of 0. That's 3 over 0 plus 4. And you get 3/4. So 0 3/4 is your y-intercept. So it's 3/4 of the way from 0 to 1 here, so somewhere around here. So now you'll recall that, let's see, actually we should look for the x-intercept. But notice if you let y be 0, this fraction's never going to equal 0 because the numerator can never be 0. One way we talked about to find the x-intercept is just let your numerator equal 0 and solve for x. Well, if you let 3 equal 0, that's gibberish, that doesn't make sense. But this fraction can never equal 0 since the numerator is 3, it'll never be 0. Fractions only equal 0 if the numerator is 0. Alright, so there are no x-intercepts, so we'll just write none. We got our y-intercept, but no other points. So now we're ready to make a table. It says graph the function, find at least 2 points on each side of the vertical asymptote. So we already have one here. I'm thinking maybe we could find one anywhere along here. Let's go ahead and plug in -3 for an x. And then on this side of the asymptote, I'm thinking -5 and -6. Alright, so I'm going to go ahead and do these by hand. The math's not so bad. F of -3 is 3 over -3 plus 4. We're just replacing this x with -3. Well, that's going to be 3 over 1, which is 3. So -3, 3 is on the graph. If we plug in -5, we'll get 3 over -5 plus 4. -5 plus 4 is -1. And so here we're going to get -3. So -5, -1, 2, 3. So we pretty much know what it's going to look like now. We're going to have an arc over here. And it's looking like we'll have an arc here. Let's just find one more point to make sure. So let's plug in -6. We get 3 over -6 plus 4. And let me see if I can move that up a little bit. That's 3 over -2, which is -1.5, or -1.5. So at -6, we're down 1.5. And so again, as this goes towards the ends, we expect the graph to approach our horizontal asymptote. As it's going this direction, it's got nowhere to go other than just closer and closer to the vertical asymptote, because you can never cross a vertical asymptote. There won't be any point when x is -4. All right, and then over here, you can see it goes like this. It's got nowhere to go but up here and towards the asymptote. And over here, we're going to approach the horizontal asymptote. So there's your graph. Now, you should be, I believe the problem that you'll be able to do the work by hand, but you could always check it on the calculator. Let's go ahead and put in, now there's two ways to put this function in. You could hit math, once you're in the y equals screen, and then arrow over to fraction if you have this feature, and notice we're going to pick n over d, that's numerator over denominator, and you can type 3 over x plus 4, and so that's kind of a nice feature if you have that on your calculator. However, if you don't, the 3 can be put in by itself with no parentheses and then divide, but because you have a binomial in the denominator, whoops, you need to put in x plus 4 in parentheses. And let's go ahead and graph, well actually we'll hit second table. And -3, that's 3, we got 3. At -5, -3 was what we got, and at -6, -1.5 was what we got. So you can see those are the points there. All right, and that's going to be it for this test. Let me know if you have any questions.